Okay. It is Wednesday, June 24th. Paul and I are recording a day early for purely selfish reasons. I have plans to go hiking in the Oregon Cascades with my family. And so, yeah, life trumps work. But we still have a great show. Perhaps we'll even be around to chat during it. We'll see if we can make that happen. We have quite the roundup of things to talk about before we get into our main topics, but I'll give you the teasers so you know that you have to stick around. First of all, we're going to be talking about North Korean state threat actor trends, so specific to Lazarus Group in software supply chain malware right now. We tend to see that they are the innovators in this space. They're continuing to innovate. So we're going to talk about what we've been seeing. And then we'll get into some general observations we have about what's going on in the supply chain world. But before we get into that, some, I guess, events, news to share. Paul, why don't you talk about the SANS podcast that you're going to be on, which by the time this airs, the podcast will have, I believe, already aired, but people can catch it on demand.
Yeah, depending on what time they might even be competing. I don't know. Oh no, it'll be early.
I think it's an hour earlier.
Yeah, it's 5:45. I'm starting out with 5:45 my time, so that shows you my commitment, y'all. Right?
Bright and early.
Yeah, no, I had a great conversation with Sean O'Connor from SANS. He knows one of my good friends, Thomas Roxia, really well, and they've been working together for a while. And yeah, just looking forward to talking at a very, this is great because it's gonna be an hour, and it's gonna be really technical, and we're gonna be talking about. I sent you, Jen, the agenda that we're gonna be talking about. So a lot of emphasis. We're gonna talk about, unfortunately, Team PCP and DPRK, of course, but going into more detail than I often can, which I'm super excited about.
Yeah, so for anyone who's going to be looking it up, we'll have the link in the show notes, but this is the SANS Threat Rundown Analysis. The name of the episode has some lovely alliteration in it. Poisoned packages and stolen secrets. I love it. The rise of supply chain attacks.
SANS post actually didn't include my name, and so I saw Sean send an email today saying, yo, what's up with Paul's name about not being in that? But anyhow.
That's okay. We'll make sure everyone knows you're there. Okay, what else is going on? In the next couple of weeks, we've had interest in bringing our first guest on this podcast / live stream. We had somebody from OpenVSX reach out, so we're working on the logistics right now. But if you have burning questions about OpenVSX specific to malware and supply chain security, or just general security about that ecosystem, would love for you to send those to us in advance to help us build kind of our run of show, because otherwise it'll just be Paul and I grilling this person. Kidding. We're going to be really nice, and we're very excited to have them interested in coming on.
Well, we're going to ask some probing questions too as well, right?
Oh, of course. Yeah. I'm not saying we're going to throw softballs, but though, let's be honest, I don't know if you've been hit with a softball, but those things are hard.
They are hard. Yeah, getting hit by in the face especially. Hey, real quick, I want to make one correction kind of related to the OpenVSX thing. When we were talking about Microsoft VS Code Marketplace a couple of episodes ago, I said something which basically, I don't have the quote in front of me, but basically I said something along the lines of Microsoft is pretty proactive about scanning VS Code extensions inside of their marketplace. And I should not have said that because I don't actually know that. I think many of the things that get turned into Microsoft are, this is what kicks things off rather than this proactive scanning that I kind of alluded to that I don't actually have proof of that exists. So I want to make that correction. I think it's less Microsoft being proactive and more, people just turning these things in when they find that they're malicious.
Yeah, so I think we'll learn a bit more about how things go on behind the curtain, so to speak. in a couple of weeks. So keep an eye out for that announcement. And again, drop us notes in the comments, DM us on our LinkedIn. Let us know what you want to hear about from this person. And then what else? Oh, yeah, no big deal. We're going to be speaking at DEF CON in the villages. So we have 2 talks accepted. The first is going to be a 2-hour workshop with the adversary village. It's titled Hunting GitHub to Identify Adversary TTPs in the Wild. Let's pause before we talk about the other one. Paul, this is a topic you're pretty passionate about. It's based on techniques that you have used in your own hunts. So talk a little bit about why we're doing this workshop.
Yeah, I mean, really, honestly, we thought when we partnered with ABX and the Adversary Village team, and we did a version of this at RSA as well, but this one will be updated. Actually, B-Sides, we did RSA and B-Sides.
You're right, yeah.
San Francisco, yeah. But yeah, what this is this teaches a set of relatively simplistic techniques to look into forward hunt in GitHub, looking for those adversary TTPs that, when the bomb maker is making the precursors, this is the metaphor I always return to, making the bomb, and they have to gather together the precursors to make the bomb. You can identify those ahead of time in GitHub if you know what to look for. And so I've been using these in production for years and years and years myself to find this stuff. And now we're going to be showing other people how to do this. And this is I also did an all-day training based on this at Melbourne B-Sides in May. So this is a technique and a process that's near and dear to my heart.
Yeah, ABX does a great job with the adversary village, so we're excited to be there. And then I will be on the AppSec Village stage. Whoop, whoop. Let me go back to the name of my talk because I forgot what it is. My talk is How Malicious AI Skills Hijack Your Agents. This is a talk that I developed earlier this year and excited to bring it to DEF CON. It has a lot of the research that we've been doing at OpenSourceMalware in it. Kind of explains why skills are such a tasty target for malicious threat actors. Well, I guess all threat actors are malicious, but you know what I mean. And what you can do to protect yourself. So if you're going to DEF CON 34, let us know. Again, the schedule is not out yet, but we'll be there. And then maybe we're still kind of in the early planning stages. We'd really like to do an open source malware meetup of some kind. So if you're interested in that, let us know. Keep following us on LinkedIn. We'll share more details about that later.
I just want to jump in here. I'm going off script. I've been wanting to do this thing in my head where we do like a CTF kind of thing inside of OSM.
I know. I really want to do it.
Yeah. So I might put something like that together that leads up to the day where we have, this happy hour or whatever we end up doing during Hacker Summer Camp. But we've got some swag as well. So we'll do something. I've already started reaching out to some of the homies.
Nice. Okay. Now, time to get into the meat. You've got in our show notes a note about your DEF CON 33 talk. So why don't we start there? What did you talk about at DEF CON last year? Why is it relevant for what we're going to talk about today?
It's super relevant. So basically, the talk I did at DEF CON last year as part of the Adversary Village it was called basically how threat actors bypass NPM, the security tools that we use to protect ourselves in NPM, or the things that are built into NPM. That wasn't the whole title, but anyhow.
That's a terrible title.
I need a workshop that. It's already happened, Paul.
Maybe go ask Claude for some help.
Well, if I could get Claude to do anything security related, I would. Yeah. So basically, it was just about how threat actors, bypass security tools to get malware into NPM. And you could also make this argument about, because I talked a bit about PyPI too as well. And now, of course, we've expanded that to talk about the VS Code marketplace and AI skills and all these other places where we're finding this stuff. But yeah, it was pretty technical talk. I had a lot of great people in the audience. I had Adnan Khan and Ronnie Carta and some of the critical thinking peeps. And it was just a really cool group of people. We all went outside afterwards, outside the room when the next talk kicked on, and we just had this like 15 or 20 people all sitting around in a circle talking. It was just like magical. I loved it. It was just so much fun. But the reason it's important for this conversation we're going to have here is because a lot of things I talk about in that talk are things that bad guys are now doing, which is not surprising, right? As we create resistance inside of NPM with cooldown periods and with, getting rid of these kind of dynamic and Git dependencies inside the package manifests, bad guys are going to use these other techniques. And that's what we want to talk about today.
Yeah. So top of the list, we've been teasing it for a couple of weeks now, is what's going on with Lazarus Group. This is the Paul show. Why don't you share what you've been seeing?
Yeah, I mean, I'm in the guts of open source malware, software supply chain malware every single day. Like literally every day, I'm in the guts of malware, looking at it, deobfuscating it, doing stuff with it. So I get to see these kind of themes up close and personal. I'm at the coalface. God, I shouldn't use that as such a dumb term, but anyhow, DPRK, North Korea. And I was talking to Thomas yesterday about this at lunch. They just innovate so much, and you don't hear about them because there's the team PCPs and all these other squeaky wheels, right? But the reality is that DPRK stole over $2 billion last year in crypto, using contagious interview and the processes around contagious interview that have evolved. And so some of those things that we're seeing now are them, finding unique ways to hide malware with this increased visibility on especially the NPM ecosystem. So the first thing that I want to talk about is something that I talked about in my talk at DEF CON last year, which is when a bad guy is deploying a net new, this is not an account compromise style takeover. This is a net new, this package is published by a bad guy and it was always intended to do a bad thing, right? What will happen is the first version will not be malicious. The second version might not be malicious. The third version might not be malicious. And at some point, they add a malicious payload. But here's the thing. Then they add another benign version after that. So what's happened is they've sandwiched.
It's a sandwich.
It's a sandwich, right? It's a reverse. Oh, I won't say that, but it's a reverse sandwich. I almost did reverse sandwich where the benign versions are, sandwiching the malicious payload. And, bad guys have been doing this for ages. DPRK has been doing this for ages, but it's now become like a motion that they're doing almost all the time or a lot. They're certainly doing it a lot. So here's the thing is that if you scan the latest version of a package and it's benign, and you have, something is flagged as potentially malicious, maybe go back and look at some of those versions in the middle too as well. It happens all the time in our analyses that, you see the last one is fine.
Yeah, like, I think maybe it would be helpful for people who are not software developers, or as you like to say, in the software sausage, to explain what mechanisms is this taken advantage of? Why does this work? Both in terms of tricking, let's say, NPM, but also tricking the consumer.
Yeah, that's a good observation to talk about. So listen, NPM has its own kind of iterative publishing process. When you do an NPM publish, you publish a new version of it, and you can choose what version number to do, or you can leave that up to NPM. But what's happening here is that the bad guys are using iterative publishing versions, right? Like 0.1.0, 0.1.1, whatever they're using. And they only add the malicious payload in the middle. Now, here's the important thing is the last version they've published is the version that you'll grab unless you specifically call the other one. And so the bad guys are leveraging this built-in behavior where if you call this package and you don't specify the specific malicious version in the middle, you're going to get the benign version. You're going to scan it and say, oh, that's okay. And I see this simple trick bypass scanners all the time. A lot of them are getting smarter and they're scanning every single version, right? But the reality is that what the bad guys do then is that when they use that as a payload, they call it from another package and they specifically call the malicious version of it. Or they do something else that's really unique is they quickly delete the more recent version and the latest tag goes back to the old version and whoop, it's that last one that former instance is much more rare, less common than the fact that they just pin to the malicious version. And this brings us to another thing, which is not on the
Well, and
list.
we saw something a little bit along this lines 1 or 2 weeks ago with the attack on Mastra or
Yep.
Maestra, where they published that easy day JS dependency.
Right.
The first version was clean, the second version was malicious. And what they did is they pinned it to the first version with a little caret, which meant you would always pull the latest. Now, it just so happens that package is still live on NPM right now, which that's a whole other thing. But anyway, I digress.
The benign one is live,
yeah. So, they're taking advantage of the various automations that are available both through NPM and just how pulling dependency versions work in order to get you to pull a poisoned version without realizing.
Yep. And so this brings us to the next part of this, which is that bad guys will then use that first package. They'll call that package as a dependency from another package, right? And they'll specifically pin that malicious version in that package. So in this technique where you're calling, we're now, when people deploy these clusters, which we'll talk about in a second, the cluster usually only, let me jump ahead to the cluster conversation because it'll just make itself self-obvious. When bad guys are publishing now, they typically will publish in a cluster, and a cluster is anywhere from 2 to maybe 10 packages, and they typically will publish these clusters close together in time. So if you look at the publishing date, it's relatively close together. And typically what happens is not all those packages have malicious payloads in them. 4 or 6 of them will call 1 or 2 of them that actually have the payload, right? And what's great about that is, let's just say at some point in the future, a researcher like myself or somebody at Socket or Keto or wherever else, gets the malicious payload taken down off of NPM. What they'll do is they'll just convert one of the benign versions that used to call that, and it will it'll now take over as the master payload or whatever, right? And these clusters, this is becoming, the standard operating, the SOP for bad guys.
Yeah. All right. So your second thing in this list is about reusing Paul and Ryder, Aptos, and BSC keys. And before you get into it, I just want to share a little story. As you know, I've been working on some onboarding workflows for OpenSourceMalware to just make it easier for people to get started really fast. And I have a list of the things we track, and crypto keys or crypto wallets are in that list. And I put it into Claude, and I was kind of having it help me with some of the logic. And it said, oh, well, crypto wallets don't belong in this list because that's really, just for Bitcoin transactions. That's not malicious. And I was like, oh, no, you're wrong, Claude.
Well, and it gets really murky, right? Because neither you or I are crypto people, right? And so I'm the first to admit this, right? So when Tron and Aptos came along, those are chains, and they have the reason that DPRK and other bad guys like those particular chains. There's 3 chains that the bad guys really like: Aptos, Tron, and the Binance BSC one. And I don't really understand much about that one at all. Don't really want to, but anyhow. The reason they like those chains is because while the thing that is stored in the chain is immutable, which is the power of the blockchain, both of those have these kind of memo components which are mutable, which you can change. And so what happens is when you make a transaction to the Aptos or Tron chains, the original thing that you stored there doesn't change, which is usually just a benign thing, right? It's just blah. It's the little memo that you're using. So because of this blockchain addresses and wallets, it's all kind of is fuzzy and stuff. But the reality is that, to your point, bad guys are absolutely using this stuff as infra. And this gets us to the next point, which is, for whatever reason, DPRK is reusing these specific blockchain addresses, and continue to reuse these memos, maybe because they've just used them in so many places. but they're out there. And if you know how to call what's in the memo, you can call it and you can see what they've updated the most recent payload to, right? So that's great. It's just as a really, like, DPRK is really good at just burning down and rebuilding, and they use AI and automation to do this constantly. Me and all the other researchers just see this constant flood of DPRK stuff. But the fact that they're reusing these particular chains from February of 2026 is really interesting, because it allows you to tie together, disparate activities under the same threat actor. And that's absolutely why those chain addresses and those wallets and, those things are in OSM. These are things that we can pivot on.
If you were like, let's take a step away from pivoting and research and talk about using it for alerting. You and I have talked a lot about the incident response related use cases. I don't know if people are thinking about alerting based on a crypto transaction in their SIEM or whatever.
Right.
So yeah, well, new things to think about.
Yeah, and at the very least, these are things that, if you are, a threat hunter, look into, kind of expanding out to look at these things. OSM's got a couple hundred of these things in them, and we're adding some, almost every day. So good thing to pivot on.
Yeah. All right. Third in your list is new campaign names. Talk us through. Why is this interesting?
Oh, listen, DPRK and all the big threat actors use campaign names. And just to kind of talk about these, there's the campaign names, and basically these are unique identifiers that DPRK will use. So a really good example of this is when you find a payload in GitHub, typically in a VS Code tasks.json file or wherever it is, but there'll be 3 lines, whether it's obfuscated or not. There'll be 3 lines where it's calling a Windows payload, a Linux payload, and a Mac payload. And each one of those has a little different designation, right? Whether that's going through a shortener, or it's going directly to Vercel or wherever it's going, or an IP address, they're differentiating that because there's different payloads. That's one thing. What they do is they add another thing, which is a campaign name, so they can track it. And it's kind of like,
it's anybody like what do they call it? Like the marketing thing.
Yeah, that's literally where I was going, like SEO GTM tags and stuff like that.
Yeah,
right?
yeah,
yeah.
URL tagging.
Yeah. And who knows? We'll never probably really know how these things map to but some people I've talked to say, oh yeah, we think it's individuals inside of these groups, right, that are tracking for KPIs or whatever, right? Like campaign 39186, is
got to check the performance.
Yeah. Right. You're handing out bonuses at the end of the year, whether it's in Pyongyang or wherever in Russia somewhere. You got to know who to give your bonuses to. Your shining star or your gold coin, your challenge coin, whatever the incentives. So what I started seeing last month is these kind of sexy campaign names, and I just included 2 here, and I included it with the packages that I found them in. But one of them was A6-Shadow-15. And we found that one in the Tailwind -color-shades NPM package. A6 Shadow 15. Now we found another one contemporaneously in the secure-box NPM package, which was A6-Orion-271. Now the funny thing is that you'll see when DPRK spins up new endpoints, whether that's in Vercel or wherever it is, they will often use those same numbers in the endpoint. So what you can do is you can begin to tie like a package to an endpoint to a campaign name, and you can kind of, and it's not, it's amorphous, and it's mostly just their automation. Sometimes it works and sometimes it doesn't, but it allows you to kind of tie together these things in this loose, relatively loose abstraction, which is really cool.
Would you say this is more of a research tactic rather than if you're actively, I don't know, doing some kind of IR in your organization? When would you do this?
Yeah, I really wouldn't use these as detection strings so much. I mean, because they're just so granular. There's just so many of them, right? But absolutely, in your research, if you're collecting these things like I am, you can begin to tie them together, inside your graph fabric, whatever you're using, right? To understand what these kind of loose, and then you can gain insights by like, okay, this is 3 npm packages and a PyPI package or whatever the case may be, you can begin to gain some insights about what's going on behind the scenes. So, and plus it just sounds cool. A6 Shadow 15. Why do they both say A6? Is that the same team? Is that the team name? And then the next one is their call sign. I'm making all this up, right? The first one is team name A6. The second one is their individual call sign. I'm Shadow. I'm Orion. I want to be Mr. Pink. I want to be Mr. Brown. Shadow and Orion. And then the last one, maybe that's the sub campaign name, where like the individual payload, right? Which is something that you see a lot. They'll tag the specific payload with a number or a unique identifier.
Or they've got a random generator running.
Could be that.
That's not as fun.
Oh, they're definitely randomly generating some of these things, like the numbers I think they're picking, because you see the same numbers, 112 and 71 and 141. You see the same numbers kind of coming up again, and they just randomly kind of associate them with other words. But in this case, I think it actually might mean something.
Interesting. So is that all you've got on North Korea? You want to move on to general stuff?
Yeah, that's it for DPRK. Let's move on to general.
All right. So this is kind of like zooming out. Some of this ties into what we just talked about with DPRK. Some of it is a little bit more unique. You've mentioned back at the top of the episode about cross-ecosystem malicious packages. This is definitely a trend we have really started to see heavily this year. And some of the research that I did earlier, looking at the velocity of new NPM packages versus new PyPI packages, malware in each, seeing those move at the same track. A lot of that velocity matching is because the threat actors are, making it a little more ecosystem agnostic. They'll get you regardless of where you are.
Yeah, 10-4. It makes sense, right? Spread the love. So, or I guess the opposite of love, but,
or something.
Whatever it is. Yeah. So I think the reason that Jen and I wanted to kind of separate these into two categories is because, the greater threat actor, threat actors are learning from whoever's, innovating the most. And so we've seen this a number of times with Team PCP, Glassworm, and others, using kind of things that DPRK Lazarus Group has been using. A really good example is the VS Code tasks.json file. That is now being used. That's ubiquitous. Like everybody's using it. And they're piling on. They're using, the tasks.json VS Code to also compromise Cursor and Windsurf and other applications that are built on top of VS Code. So it makes sense. But same thing with, the canisters and a number of the other things that DPRK first innovated. We now see that being used in a broader context by more threat actors. And so some of those other things that we've seen is that just the fact that everybody is now building in more than one ecosystem, or almost everybody is building in one ecosystem. Used to just be the Glassworms and DPRK, and now that's not the case. This week, I've been looking at a number of clusters from Chinese threat actors, Indonesian threat actors, and Russian threat actors. All three of these are low-end, low-technical. These are not APTs. These are anti-APT groups that are using vibe coding to quickly build payloads in multiple languages that they can then apply to different package ecosystems, right? So you're seeing, and if you burn down to the actual payloads, they're typically either the same or very, very similar. And they might use, different, PyPI they'll detonate in a different way there than they will in other places. But this is something we're now going to see because of vibe coding, vibe hacking. We'll see this across all stratuses of threat actors, the low, crappy ones all the way up to the nation states. So
I think it bears explicitly stating what this is telling us. And, I think most people understand this is don't just look at NPM. I think we've been a little bit conditioned to see NPM as the sole problem or the sole source. And that has been somewhat true just based on sheer numbers, right? There's hundreds of thousands of malicious package threat reports just at NPM. But if, for example, you're only tracking malicious NPM packages, even though you're using other languages, then you're leaving yourself open. And if you're really focused on just the security improvements that are happening in the NPM ecosystem, like understand that those are not automatically the same in other ecosystems. So for example, if you're already using open source malware to find out the new npm packages that we've added every day, maybe add PyPI, maybe add VS Code. Think about broadening your data that you're pulling in.
Right. Yeah, 100%. I don't have anything to add. Exactly.
No notes. All right. You talked a little bit about clusters already in the context of DPRK. Do you have more to say on that?
No, just again, this is something, the reason it's in this category is because just everybody's doing it now, right? It used to be that the DPRK would, publish these kind of clusters together, and they'd have those campaign names, and you could tell kind of roughly what the abstraction is. Now everybody's doing it. They're all coming in these clusters, and it makes sense. And they're also modifying not each one of the things, the way that the benign package, we'll call the malicious package, changes, right? And we're seeing a lot more, this isn't on the list, but we're seeing a lot more dynamic imports inside of the code rather than in the package manifest, because the npm package manager and the upgrades to the security around npm package manager itself don't help there at all. So we're seeing more of this.
Yeah, why don't we pause on that? Because I'm not sure, I've been hearing a lot of people talking about it, and I'm not sure everyone understands, again, if they're not involved in software development, how dynamic imports work. So let's go a little deeper on that.
Yeah. So I like this. So what was it? Today is Thursday here. So it would have been Monday or Tuesday my time here. I jumped in to look at a user source code. And the first two lines I noticed in this particular package repository were lines 1 and 2 were importing from URLs in the JavaScript additional JavaScript, right? And this is totally legitimate, happens all the time. These dynamic imports, when you basically, when a JavaScript file runs in your browser or in whatever V8 engine you're using, it can call additional dependencies in the code from URLs. And guess what? Your package manager can't find that. Your package firewall can't find that. Your proxy can't fire that. Artifactory can't deal with that. Basically, none of the security tools that you're using can help you with that. Like there are things in the source.
It mirrors a lot of what we saw with malicious AI skills earlier in the year, where the skill itself is benign, but it's saying, hey, you need to go over to this outside thing to download the CLI or whatever. Are you seeing this predominantly in JavaScript because of JavaScript's tendency to bring all its friends?
Yeah, I mean, I'm mostly seeing, and I'm seeing a lot in vibe-coded apps, and that's because they're being written quickly. They're not having a lot of oversight. I'm seeing it a lot in lambdas and other kind of transient compute kind of code snippets. So these are things to look for. I'm actually looking at building something to try to identify these things. But just to say this very explicitly, as the npm ecosystem adds protections around the package manager, right? And we're all making a big deal about, npm version 12 coming with these things, and all those things are good. Again, these are all great things. Bad guys are going to find a way, and one of those ways is to drop or to leverage dynamic dependencies you've already got, or find some way to add some, another way. Or here's the other thing: is a lot of these dynamic dependencies get pulled from CDNs that you've never heard of. Little known fact: there's like 150 JavaScript CDNs just in China. These are all just, managing the Chinese developer market, and they're all kinds of crazy. And how would you know one URL is malicious versus, you just have no idea. And so you've got some code of yours that is calling a dynamic dependency from something that is a CDN or ostensibly a CDN. You have no idea. So now you got to go and research that thing. What is this, right? ESM.sh. What the hell is that? Oh, it turns out that's legit. What about this next one? js-deliver.com. js-deliver.com is legit, but js-deliver, is that? Oh, shoot. That looks like that might be malicious, right?
I have questions. And I'm just thinking about logistics here of, okay, once you know what's bad, what do you start labeling as malicious at that point? What do you start tracking? Do you track the package that contains the dynamic dependency, which may or may not be intentionally sharing something malicious? Because as we know, there's lots of stuff out there that wears, I don't know, friendly hat, but has something else underneath. Do you track it as malicious URLs? What's your thought? Like, how do you think you track this kind of stuff? How do you look for it?
Audience at home, this is not a setup. Like, this is Jen actually asking a question that we've never talked about before.
Yeah, I don't know.
Jen, in OSM, we actually do both. We track that's a great question. I've had to deal with this myself because do I track the CDN? Yes, absolutely I do. So for example, if I find that there's a malicious CDN or something that has been consistently delivering malicious packages, I will add it, or somebody else will add it to OSM as a top level domain, right? First.
Malicious domain category. Okay.
Yes, ma'am. Second, when I found a specific payload, and I did this several times yesterday, of malicious payloads, I will add the full URL into OSM because a lot of times that's actually not a malicious CDN. It's just a malicious payload being called from a CDN, right? And it's where it's getting that. It's getting that from GitHub somewhere. Who knows where it's getting from, like Codeberg or who knows, right? But the point is that it's serving it up to you. And some of these things are already pre-built as ESM modules, and some of them are, there's all kinds of different ways to do this. So you have to cover off both. And I ask you, audience, what security tool are you using right now that does both of those things, right? Protects you both from these domains that you've never heard about, these weird CDN or fake CDN, malicious CDNs, and the payloads themselves. That is a bad mofo.
That's no fun. Okay, last item on here, which I don't think we've hit yet, but this falls into the category of threat actors getting creative to evade detection. And this is the idea of splitting the payload into multiple pieces. And you've got an example here where you're seeing it split into 4 pieces. The URL is in one JavaScript file, a protocol is in another JavaScript file, the path is in yet another, and the post is in yet another. What are some examples like that you can share where you've seen this, in reality? This is not a hypothetical researcher, well, they could do this kind of a thing.
No, I've seen this multiple times this week. No, it happens quite frequently, and it's going to happen more and more because there's so many people that are analyzing, packages as soon as they're getting deployed. It makes sense for the bad guys to chunk up their payloads into separate pieces and then publish them, and then either call things, via dependencies or find other ways to import.
Are they like different functions in the same package, or are they?
Oh, I see.
Like transitive dependencies? How are they?
Good question.
Making the lines connect? Both. Okay.
Both. Yeah. It's obviously easier when the files are individual JavaScript files or TypeScript files inside of a package, right? They can just call each other from the code and bundle together the payload in the way you go. But I am also seeing at the same time multiple packages. Say if we take one of our clusters, let's just say 4 packages, right? They'll kind of chunk up the payload across those 4 packages, and they will then bring them together via dependent. Now that's a much trickier thing. It's much, if one of those packages gets burned, removed, deleted, yoinked. Thank you. Gets yoinked. Suddenly your payload no longer works, right? So it's a trickier, riskier thing for the bad guys to do. Very, very common for people to do this in individual JavaScript files inside
within
of
a single
package.
Yeah.
Very, very common to do that. Less common to do the other.
Makes sense.
That's a good question.
Yeah, I didn't know. It's worth asking. Okay, that's the end of our list of things. We've made it a little over our normal recording time, so I think this is probably a good place to stop. But yeah, this has been super interesting. Thanks for answering my questions, Paul.
No worries. Great questions, Jen.
Happy to do it. All right, take care, everyone.
I see you guys. Thanks for listening. Appreciate it. Bye-bye.